In this video, we are going to talk about isotopes. In order to discuss isotopes, we're going to have to talk a little bit about what's going on within the nucleus of an atom. Now, the atomic number is the number of protons in a nucleus, and the atomic number is always going to be the whole number on the periodic table for an element. So the atomic number for gold is 79. Well, since that atomic number also tells us the number of protons in a nucleus, that tells us that gold has 79 protons. So an isotope is going to be where atoms of the same element, so they have the same number of protons, have different number of neutrons. Now remember, protons define the identity of the atom. The electrons are going to define the charge of the atom. So if you have the same number of protons and electrons, then it's going to be a charge neutral atom. Now, the number of neutrons is going to define the mass of the atom. And that is because if I take neutrons away or add neutrons, I'm not going to be messing with the charge since they're charge neutral. I'm not messing with the identity because that's the proton's job. So the only thing I'm really affecting is the atomic mass. So I can have an atom that has different isotopes, and those different isotopes are going to have different atomic masses. Now, the mass number, which is given the symbol capital A, is going to be equal to the number of protons and neutrons in the nucleus. So the mass number is going to be equal to the protons plus the neutrons. And this is going to be specific for each isotope. So this will define your isotope. It'll tell you which isotope you are dealing with. Now, something that is very difficult for people when they're first learning chemistry, the mass number is not the same thing as the atomic mass. They are very different. The atomic mass, which can be found on the periodic table, it's going to be the thing that has the decimal points, is not the same thing as a mass number. You cannot find the mass number on the periodic table. The mass number is not on the periodic table. It has to be provided for you. So when you are dealing with an isotope symbol, you are going to have the element symbol, and then it's going to show the number of protons in that element. And you can get that from the periodic table, the atomic number. And then up here, this is going to tell you which isotope you're dealing with because it's going to tell you how many protons that you have. So here are some different isotopes of hydrogen. We have protium, which is hydrogen 1. So if we look at what hydrogen 1 is made of, it is going to have no neutrons, has a mass of 1, so it is going to have 1 proton. Since it is charge neutral, it has 1 electron. Hydrogen 2, deuterium, is going to have a neutron. So that's the difference between hydrogen 1 and hydrogen 2. Notice that these numbers right here do not change. Remember, if I change the number of protons, I'm changing the identity and I'm no longer dealing with hydrogen. If I change the number of electrons, then I am no longer dealing with a charge neutral atom. Now, if I change the number of neutrons, the only thing I'm changing is the mass. So hydrogen 3 that has 2 neutrons and 1 hydrogen or 1 proton is tritium, and this is used a lot in lighting. So if your light watches up, it might have this compound in it. Hydrogen 1 is the most common form of hydrogen available. Deuterium is not very common at all. It does not naturally occur. All right, let's get some practice with writing these different isotopic symbols out. So write the atomic symbol for the following isotopes. A bromine atom with 46 neutrons. So in order to do this problem, I need a periodic table. So you might need to pause the video and go grab your periodic table. All right, hopefully you have your periodic table. The first thing I need to do is find bromine on my periodic table. I see that bromine has a symbol of BR, capital B, lowercase r. And the atomic number for bromine is 35. So remember, we put the atomic number right here. Now, a huge mistake I see is that people want to take the neutrons and put it up here, but that is not correct. Remember, we have to put the mass number up there. So that means I need to calculate the mass number. So the mass number is equal to the number of protons plus the number of neutrons. So for this example, I'm going to take 35 plus 46, and that will give me my mass number. So my mass number is going to be 81, and I can take that and put it in my isotopic symbol. So this will be my final answer here. I have bromine 81. So bromine 81 can either be given like this, or if I wanted to write it out, it would be bromine dash 81. The reason we don't say 81 bromine is because that makes it seem like we're dealing with 81 bromine atoms. All right, now if we want the nuclear symbol for bromine 81, then we would have to include that atomic number. All right, let's look at an atom containing 15 protons and 17 neutrons. So the first thing I'm going to have to do with this example is go and look at which element has 15 protons. So I look at my periodic table, find the element that has an atomic number of 15, and that is phosphorus. So I can write a P here. Since I already know it has 15 protons, I can write a 15 where the atomic number goes. And then to get my mass number, I will just add my 15 and 17 for a total of 32. So this isotope would be phosphorus 32. All right, in this next example, we're going to determine the number of protons, neutrons, and electrons in each one of these isotopes. So the first one we're dealing with is uranium 238. So again, I can get my periodic table out, find uranium on the periodic table, and I can confirm that it has an atomic number of 92. So my number of protons is going to be equal to 92. Now, since this is charge neutral, there is no charge, then I know the number of electrons have to be equal to the number of protons. So we have 92 electrons as well. Now I can calculate the number of neutrons using the mass number. So my number of neutrons is going to be equal to the mass number minus the number of protons. So it's going to be 238 minus 92. Calculate that out. If we take 238 minus 92, what do we get? Yes, we get 146. So the number of neutrons is equal to 146. Notice the number of neutrons is not equal to 238. Remember, that is your mass number. All right, go ahead and take a minute to pause the video. When you get the answer to B, you can come back and check it out with me. All right, hopefully you took a minute to pause the video and we can go over this next one together. So in this next one, we have iodine. The atomic number is 53. So the number of protons I have is 53. It is charge neutral, so the number of positive things and negative things have to be equal. So I know that I have 53 electrons. Now, to determine the mass number, I have to take the mass number minus, or sorry, to determine the number of neutrons, I need to take the mass number minus the number of protons. So I can take this 131 and subtract 53. So sometimes you can think of it as just putting a little negative sign right here to get the number of neutrons. And when we do this, we get 78. So the number of neutrons I have is 78. To get more practice, you can fill out this table. I will fill out the first part, the first row with you, and then I'd like you to fill out the remaining 3 rows on your own. If you email me your answers, I will give you extra credit on your chapter quiz. All right, so my isotope name is chlorine 35. So I need to look up my symbol for chlorine, which is Cl. I can look on the periodic table to determine what the atomic number for chlorine is, and that will tell me the number of protons. So I have 17 protons. Well, I know this is charge neutral because there are no charges indicated, so the number of electrons also has to be 17. The mass number is provided for me right here, 35. Notice that I do not put 35.453 because that's the atomic mass. And we want the mass number, which will never have a decimal point because the mass number is equal to the number of protons plus neutrons. I can count those. That is an exact number. So finally, I can subtract the mass number. I can take the mass number and subtract the number of protons to determine the number of neutrons. So what do we get for that? Yep, that's what I get as well. We get 18. Now, if you do this and complete the rest of the table, then and send it to me to check your answers, I will give you extra credit for the ones you get correct. Now, the last thing I want to talk about with isotopes is atomic mass. And like we said before, atomic mass is not the same thing as the mass number. The atomic mass is found between or beneath the atomic symbol on the periodic table. It is generally going to have decimal points. So the atomic mass is found right under carbon on the periodic table, and carbon has an atomic mass of 12.011. Notice that I cannot look at the periodic table to determine how many neutrons there are. I can't look at the periodic table to determine the mass number. Now, the atomic mass is the weighted average of the naturally occurring isotopes. Now, this is important. It does not include the radioactive isotopes or the synthetic isotopes. It is the naturally occurring isotopes. So, let's look at an example. The naturally occurring isotopes of carbon are carbon 13 and carbon 12. Which isotope occurs more naturally? So, in order to solve this problem, I need to look at the atomic mass of carbon. Notice that the atomic mass of carbon is much closer to 12. In fact, it's really close to 12 and kind of far away from 13. So carbon 12 will occur more naturally because it is much closer to the atomic mass for carbon than carbon-13. So these are the types of questions you can expect to see. You are not going to be calculating the atomic mass, but I can ask you which isotope occurs naturally more.